for years, if you wanted to get into, serious AI modeling or deep learning, you hit this wall, a really expensive one.
Yeah, the hardware wall. You needed these specialized, powerful GPUs or just a massive cloud budget. It felt kind of out of reach for most people.
Right, or like you needed a grant from a university or something just to get started.
Exactly. It was a real barrier. Your cool idea could just stall because you didn't have the cash for the hardware or even the time to figure out the setup. Pretty demoralizing.
Well, that wall, the one that basically defined AI development economics for like a decade.
Yeah.
It's kind of gone now.
Remarkably. And welcome to the deep dive. We've been digging into sources that give a really solid guide to Google Colab. It's this free tool, runs right in your browser, and it honestly puts a high-powered AI lab right at your fingertips. This isn't just, some handy utility. It's a direct shortcut to building AI stuff no matter what your budget looks like.
So our mission today is pretty clear. We want to understand how Colab is structured, how its sort of unique cell system works.
Yeah, and then we'll hit the key features that make it so powerful.
And maybe most importantly for you listening, we're going to cover the common mistakes, the things that catch pretty much every new user so you can avoid losing time or worse, your work.
Right. But get these few things down, and you can basically jump straight into building without those early headaches.
Okay, so let's start right there. What is Colab exactly? So Google Colab, it's short for collaboratory people, often call it the Google Docs for code.
That's a great analogy.
Yeah, it's collaborative, you can share it easily, and crucially, zero installation needed. No setup on your own computer. You just log into Google and boom, you've got a coding environment.
And it is like Google Docs in that way. Under the hood, it's basically a cloud-hosted Jupyter Notebook. But the really revolutionary part, the game changer, is the free access it gives you to some seriously powerful hardware. We're talking GPUs and TPUs.
Okay, so GPUs and TPUs. If you've got a new to this, these are special processors. They're designed for the kind of math. Deep learning needs tons of calculations all at once. They speed things up a lot.
Yeah, think of it like this. Your regular computer chip, the CPU, it's like a really skilled chef, carefully making one complex dish.
Okay.
A GPU. That's like an army of line cooks, all making thousands of simple things simultaneously. The speed difference is honestly pretty wild. Our sources mention a model that might take, say, 8 hours on a decent laptop, could finish in maybe 15 minutes on Colab using these free accelerators.
Wow. That kind of accessibility, it really does level the playing field, doesn't it?
Totally. Students, founders trying to bootstrap something, researchers anywhere, they can all jump in. Learning suddenly just costs your time, not a pile of cash.
So what would you say is the single biggest impact of that free access for someone just starting out?
It just removes the money barrier completely. Anyone can start building AI right away. All right, so to actually use that power, you need to get the hang of the basic structure first, which is the Jupyter Notebook format. It's built out of these little independent blocks or cells.
Right. And each cell holds either code, usually Python, or text, like notes or explanations, using something called Markdown. And this cell-based approach is really key for efficiency, especially with data work. Like imagine you have a big 10-gigabyte data set you need to analyze.
Okay.
Cell 1, maybe you load the data, takes 5 minutes. Cell 2, you clean it up, do some processing. Cell 3, you make a chart, a visualization.
Got it.
Now, let's say you just want to change the title on that chart. You only need to rerun Cell 3.
Right.
The data loaded in Cell 1 and processed in Cell 2, it's still there, loaded in memory for that session. You don't have to wait another 5 minutes just to change a label, which saves a ton of time when you're tweaking things.
Okay. But that flexibility also leads to maybe the biggest point of confusion for beginners, right?
Oh, yeah. Execution order versus cell position. This is crucial. The cells look like they're arranged top to bottom, like a document.
Yeah.
But they actually run in whatever order you tell them to run. You see those little numbers and brackets next to the cells, like 1, 2. That's the actual execution order for your current session. And this is where it gets messy. You could, scroll way down to cell 5 and define some important variable there.
Yep.
Then you scroll back up to cell 3 and try to use that variable. But if you haven't actually run cell 5 yet in this session...
Exactly. Cell 3 crashes because the variable doesn't exist yet as far as the execution kernel is concerned, even though you can see it defined lower down on the page.
It's like trying to use step 5 ingredients back in step 3 of a recipe.
Perfect analogy. It hasn't happened yet in the process.
So why is getting your head around this execution order thing so critical for debugging?
Because getting cells out of order is probably the #1 reason for weird results and frustration when you're starting out. Getting going is super simple, though. All you need is a Google account. Go to colab.research.google.com. You can run a quick test like print, "Hello, Colab."
Right.
And that confirms everything's ready. Python's there, NumPy, Pandas, TensorFlow. The whole data science toolkit is pre-installed, ready to go.
Okay, let's talk features. The things that make this more than just a simple notebook. Number one have to be getting that free supercomputer access.
Definitely. You just go to the runtime menu, click Change Runtime Type, and pick GPU. Usually, the free one they offer is something like a Tesla T4 GPU, which is pretty powerful.
Yeah, tell us about the T4. What's the deal with that specific chip?
So the T4 is really good, especially for what's called inference, that's running a model after it's already trained. It's also decent for medium-sized training tasks.
Okay.
It's not designed for, like, training a massive model for days on end, but for learning, prototyping, getting things working. It's fantastic. It's a game changer for free access.
And they've also got that AI assistant built right in now, Gemini.
Yeah, and it's not just some generic chatbot. It's context-aware. It actually knows about the code in your notebook.
Ah, that's clever.
It knows your variables, the libraries you've imported, even the error message you just got. You can highlight some code that makes no sense and ask it, like, explain this like I'm 5. And because it has the context, the explanation is usually spot on. It really helps you learn faster.
That sounds incredibly useful. Another big one is GitHub integration, right?
Yeah.
That feels important for more serious work.
Oh, huge. It connects Colab directly to how professionals actually manage code. You can open notebooks straight from a GitHub repository, make changes, save them back, commit them all without leaving Colab.
Nice.
And visualization, too. Libraries like Matplotlib or Plotly, they just work out of the box. You run a code cell to make a chart, and boom, the interactive chart appears right below it. Instant feedback.
Yeah, seeing the result immediately like that must really speed up exploring data.
So beyond just the speed from the GPU, what feature really makes Colab great for sharing your work or research?
The mix of Markdown text and runnable code. It lets you create these documents that both explain and demonstrate fully reproducible.
Okay, let's shift gears to the warnings. The common traps. We talked about the time traveler problem, that execution order confusion. Right. And the quick fix, maybe the slightly brute force fix, if things get weird, is runtime, run all. Clears everything and runs top to bottom.
But there's a bigger potential tragedy, isn't there? The great disconnect.
Yes. This one hurts. Colab runtimes, the virtual machines you're using, they're temporary.
How temporary?
Well, if you're idle for about 90 minutes, it might disconnect. And there's usually a hard limit, maybe 12 hours total session time on the free tier. When it disconnects,
Everything's gone.
everything that was only in the machine's memory, your variables, your loaded data, that model you were halfway through training, poof, gone instantly.
Oh, man. 6 hours of training just vanished.
Yeah.
Okay, so what's the absolute must-do defense against that?
You have to save anything important somewhere permanent. And the standard way is mounting Google Drive.
How does that work?
It's just a little code snippet you run. It securely links your temporary Colab session to your personal Google Drive storage. Think of Colab like a shared desk that gets wiped clean every night. Google Drive is your personal, locked filing cabinet. Anything you save only to the Colab machine's temporary disk, the content directory will disappear when the session ends. Mount Drive, save there.
Yeah, I gotta admit, even now, sometimes I'll tweak a variable in one cell, forget to rerun it, then spend like 5 minutes debugging something else entirely.
Happens to the best of us.
Only to realize the change I made never actually executed. It's just part of the notebook life, I guess.
And related to that is the temporary storage trap. That content folder seems like a place to put files.
Right, you download a data set there.
Exactly, maybe using a shell command. But if you don't immediately copy or move that dataset to your mounted Google Drive, it's going to vanish when the session resets. Poof. So if I've got a really important long training job running, what's my absolute minimum safety net against losing work from a disconnect?
Definitely set up checkpointing, save your model's progress frequently to Google Drive. Okay, enough about avoiding disaster. Let's talk about creating cool stuff. What can you actually build with this for free?
Well, it's great for training reasonably sized models, like taking a pre-trained image classifier and fine-tuning it for a specific task you have.
Makes sense.
And it's perfect for prototyping. Got an idea for, I don't know, a slogan generator app using a language model?
Yeah.
You could probably fine-tune a model in Colab, wrap it in a simple interface, and have a working demo in an afternoon, all free.
That's pretty cool. What about other areas like audio?
Oh, yeah. You could use something like the Whisper library right inside Colab. Take an hour-long audio file, transcribe it, get a summary, maybe analyze the sentiment, all in one notebook file you can share.
Okay, so where's the line between the free tier and when you need to pay?
So the free tier has limits. You don't get guaranteed GPU access. Sometimes they might not be available. Usually you can only run maybe 2 notebooks at the same time. And RAM is typically around 12, 13 gigabytes.
Which is decent for learning, but maybe not for huge projects.
Right. That's where Colab Pro comes in. It's about $10 a month last I checked.
And what does that get you?
Priority access to faster GPUs, things like the A100 or V100, which are much more powerful. Also, longer run times, like up to 24 hours, and significantly more RAM, sometimes up to 50 gigs or more.
So the A100 versus the T4 we mentioned earlier, what's the real difference?
Think architecture. The A100 is just a beast. Built for massive parallel processing, really designed for speeding up those huge multi-day training jobs. You pay for guaranteed access to that kind of premium horsepower.
So when should a startup or maybe a solo founder absolutely make the jump from free to pro?
I'd say when your training really needs to run for more than 12 hours consistently, or if getting access to those top-tier GPUs becomes critical for hitting deadlines. Okay, let's get into the Colab Ninja stuff. Advanced tricks for people who use it a lot.
Oh, okay. Ninja tips.
Ninjas love magic commands. These are special instructions in a cell starting with percent, like just putting percent time at the start of a cell.
Yeah.
It'll tell you exactly how long that one cell took to run. Super useful for finding where your code is slow.
Finding bottlenecks. Nice.
What else? Shell commands. Using an exclamation mark at the start of a line lets you run Linux shell commands directly on the cloud machine.
Like what?
Like wget URL. This downloads a file directly to the Colab machine super fast, bypassing your own internet connection. If you're grabbing a 50 gigabyte data set, huge time saver.
Wow, okay. That's a good one.
And security. This is crucial. Use the secrets feature. There's a little key icon in the sidebar. Use that to store sensitive stuff like API keys, your OpenIAPA key or whatever. Never, ever just paste keys directly into your code cells, especially if you might share that notebook on GitHub later. Big no-no.
Right. Keep those secrets secret. It seems like all this integration, GitHub, Drive, the shell, really smooths out the workflow, doesn't it?
Totally. And it leads to this idea, Colab is the lab where you experiment and develop. It's not usually the factory where you run a massive production service.
So the process is develop in Colab, train the model, save the important results the trained weights.
Exactly. Save those weights securely to Drive. Then you take the core logic, rewrite it cleanly, maybe as a standard Python script, and deploy that script to a proper scalable server for users.
Gotcha. Lab first, then factory.
Whoa. But just imagine, though, scaling something up to handle like 1 billion queries a month.
Yeah.
And the core model was developed entirely for free, maybe just 6 months after you first learned Python on this very platform. That's kind of wild. That's the power here. Okay, quick ninja question. What's the one keyboard shortcut that saves the most time day-to-day in Colab?
Oh, easy. Got to be Shift plus Enter.
Yeah.
Runs the current cell and immediately moves your cursor to the next one. Keeps the flow going.
Yeah.
So wrapping up, Colab really has knocked down those big barriers, hasn't it? Cost and complexity.
It really has. It's the great equalizer. Puts powerful AI tools in everyone's hands right in their browser.
Yeah, anyone, anywhere.
And the notebook format itself, that mix of text and code, it encourages reproducible work. You can share not just your result, but your entire process. It's the ultimate show, don't tell.
So, for everyone listening, you basically have a free supercomputer available right now. Here's a thought. What's the smallest, maybe weirdest, but interesting data set you can find online right now? Something small enough to just try loading and making one simple chart from in your very first Colab notebook.
Yeah, take what we've talked about, open up colab.research.google.com, and just start building something. Give it a try.
We'll catch you on the next deep dive.